Okay, good morning everybody. So yesterday we stopped at this point. We looked at this array example. And we looked at this overloaded constructors, and that was the example that we gave you. Constructors, overloaded constructors, many of them, they are calling each other, and there is a main constructor that handles all the stuff actually. This constructor that takes hour, minute, and second, and it uses a set time, but all the other constructors, they call this constructor. Also, there is a copy constructor in C++, what we call as a copy constructor. In Java, we don't call these as copy constructors because copy constructors are not distinguished from any other constructors actually. This is a constructor and this is another constructor. We don't call them copy constructors. In Java, to make copies of objects, we don't use the copy constructors. We use clone method, which is defined in the base class object. Okay, and set time works this way, and we already know that. Okay, so we looked at this one and we stopped. Any question from yesterday? Okay, let's move on then. I talked about this garbage collection a few times. So the garbage collection is a method of deleting unused objects in the heap, and in fact it is the only way that I know of, other than the exceptions, other than the some rare cases. So garbage collection does this. It runs from time to time. Think about it like this. It runs from time to time. It checks all the objects and their reference counts. If there are objects with 0 reference counts, then it deletes them. That's what the garbage collection does. So it's a software procedure, of course, and it takes time and memory, CPU time and memory. That's why it kind of slows our system a little bit down. But if you have enough memory, if you have enough CPU power, then it shouldn't be no problem. So the garbage collection definitely should work with the reference counts, and reference counts are so important. That's the main difference between the C++ shared pointers or smart pointers and the Java references. You never delete a Java reference yourself, and you don't know when the object is deleted actually. I mean, even if the reference count is 0, garbage collection may not run until your program ends. Okay. Before the object is deleted, when its reference count reaches 0, okay, before it is deleted, this finalize method of each object is called. Okay, this is like the destructor in C++, but they are not the same, of course. They are very, very different. Why? Because I don't know when the destructors are going to be called. When I delete a dynamically created object, the destructor will be called. When the object is deleted, because it's an automatic object, it is created on the stack and it's a local object. In that case, when the scope is gone, then the object is deleted. I know when the destructor is called. We don't know when the finalize is called because it depends on when the garbage collection starts. We have some control over it, but this is not typical Java programming style. You don't think about when the objects are being deleted. Okay, so but whenever they are deleted, okay, whenever they are taken out of the memory, this finalized method of that object is called. So in a way, I maybe to just to remember it. Okay, of course they have differences between those. Okay, let me add a few. Let me add a few lines here. Okay, so even more maybe. Okay, so C++ destructors. It's kind of finalized, but of course it is not the same thing. Okay, so maybe I should kind of put it in quotes because they are not exactly the same. Okay, they are not exactly the same, and constant final, they are not exactly the same. Nothing is exactly the same, of course, but some of them are very, very similar. For example, using and import, again, there are some differences. Okay, so we already know the rest of them. Let's go back and let's see one example that uses this finalize method. As I said before, finalize is inherited from the object class. All the classes that you write in Java, they have to be inherited from this object class. So all of them inherit this finalize method. Okay, I have a class named employee, a familiar class. Very simple class in this case. It's going to have a first name and last name, and that's it. Not even a social security number. And there is a private static integer count, and it is initialized to 0. Okay, so it's a private integer. That means what? I am going to count the number of employees that I have, I guess. Yeah, because I am incrementing it at the constructor. Okay, so this is my constructor. First name, last name, set it. Increment the constructor, and I have a nice message that says that I have constructed an object of type employee with his first name, last name, and count. Okay, and here is our finalized method. It is protected because it was protected in the object class. I inherited it. I am still using it as a protected object, a protected method. And when an employee dies, I decrement this counter, static counter, so I know how many employees are alive. But well, this is kind of not correct, because even if I consider an employee dead, I am not using any employees. This reference count, the counter count, doesn't reach to 0. Why? Because I don't know when the objects are going to be deleted, right? So this is not like the destructors. In the destructors, I definitely know, okay, this is my, in C++, this is my employee E1. I do some stuff. I know that this E1 will be deleted here. I know that. And the destructor of E1 will be called here. But in Java, even if I do this, new employee something, even if I do E1 gets the value of null, I am not sure if this employee is deleted at this point, because reference count reaching 0 doesn't mean that the garbage collector will delete my object. Okay, that's why this count doesn't tell you exactly how many employees are alive at that moment. Okay, so you don't have the full control in there. And regularly we have our first name, guest name, etc., and this stuff. And I have this get count, the static method get count. Okay, static method get count, and it just returns the static data member count. Okay. Okay, good. In Java, I think we talked about this. Static data members of C++. Okay. I think we talked about it. Yeah, data members are fields or instance variables. Okay, static data members. Data members are called class variables. Remember, non-static data members are called instance variables. Now they are called class variables. Did you get the logic? I mean, the static data members are like variables of the class itself. The employee class has a counter variable in it. The whole class has one variable. But for the data members, each object, each instance has a variable in it, right? So if I look at this one, if I look at this one again, each employee object should have its own first name and last name. So these are the instance variables. Each, the whole employee class has just single count. That's why this count is a class variable. These two are instance variables. That's the terminology, and I think that's the right terminology today. The names fit perfectly the meaning. Okay, instance variables and class variables. So this method is a class method. You call it on the classes. Okay, it works on the class variables. Okay, so let's see our main method inside this employee test. A second class employee test. Employee test says that before I start, I am going to call this getCount on the employee class because getCount is a static method. So it's going to return a 0, right? Because there are no employees created yet. So when I make two employee objects with these names, Susan Baker and Bob Blue, okay, E1 and E2, I make two of them. You know you remember the constructor. Constructor says that I am going to increment count by 1, and I'm going to do these assignments, reference copies, no string copies there, reference copies, and I will print this message. So it's going to say Susan Baker employee number 1 and Bob Blue employee number 2, right? So it will do those, no problems. And then I will do this print line. I would get the get count from E1 and E2. Well, they are both calling the same method, and they are both working on the same data. Both of them will print 2, right? Because E1 get count and E2 get count, they are calling the same method with the same data. Because get count is the static method or the class method. Okay. So this one will print 2, this one will print 2, and this one will print 2 again. Okay? Good. And then I have this, get names of employees. Okay? So I am going to print these, get first name, get last name. Of course, this will be Susan Baker, Bob Blue. And then after that, I am going to do this, 31 and 32. Okay? E1, E2. Both of them are assigned null values, So I expect at line 33, if I print employee get count, I may get 0, I may get 2, and I may get 1, I don't know, because I didn't know what objects are deleted. I don't know if any objects are deleted at all. But after line 34, if I force the garbage collector to run, that's how you run the garbage collector. You ask the garbage collector run now. It runs the garbage collector, and all the garbage will be collected. References with count 0 will be deleted. Then after that, when I call this employee get count, I will get 0 back because employee finalize method decremented the count by 1. So this is the output actually. So finally, after GC, I get the result number. Okay, 0. And finalizer, okay, these two are not called by myself. It is called by the garbage collector. Every time finalizer called, on the object, count is decremented by 1, of course. Okay? Any questions so far? Okay, finalize method is kind of destructor, but it is very different from destructor, as I said. The way you write it is similar. Okay, its name is not tilde class name. Its name is finalizer. Okay, finalize. Its name is finalize, and it is written like the destructor. Okay, it doesn't take any parameters, and it looks like it returns a void. I mean, it's different from destructor, right? Destructor don't return anything. This one has to return a void because it is part of the object class, and inside the object class, all the methods has to be regular methods, including their return types. Okay. Good. Any questions? I am getting cold here. Yes.
Here, finalize method is overwritten.
What do you mean? Finalize method is already what?
Overwritten.
Yeah, sure. We override it because there is a default finalize method.
Yes, I'm thinking the virtual functions in C++.
You mean should I make my finalize virtual? Well, I mean, we will talk about it. In C++, in Java, everything is virtual. This is virtual, this is virtual, this is a static, it is not virtual. But everything you write is a virtual method. Okay? If you don't want it to be virtual, okay, you say it's final. Okay? Final methods are not virtual, and they are not overridable. Final means that don't override this method, right? And what does that mean? It means that I am not going to make new meanings of it. So that means it's going to be early binding, okay, and that's going to be not virtual.
Also, why protected keyword is used?
Say it again.
Why protected keyword is used?
Because finalize is protected in the base class. Doesn't matter, I am not calling it anyway, right? I mean, nobody calls it, but it is protected. Good. Any other questions? Okay, so let's move on then. Let's move on. We looked at the finalize and final instance. We talked about this final before. Okay. It's like const, but it is not exactly const. For example, there is no const method in Java. You cannot say that this method is not going to modify anything, okay? And if you make one of your parameters, for example, when you say, I have a method, it takes a money object, okay, MO, okay? So of course this is not a money object, this is a money reference. When you say final money MO, okay, it doesn't mean that I won't change the object that is referenced by MO. It means that I am not going to change MO, okay? So I am not going to say, I can say this is okay, MO dot set dollars, $10. This is okay, no problem. But if you say MO gets a new money, okay, this is bad, okay, because you said that MO is a final, it's a constant, right? So the meaning is a little bit different. So that's why we say that constant and final are not exactly the same, but they are kind of similar. Okay, and as I said, there are no constant methods in Java. If you say this method is a final method, then that means I am not going to override that method. That's the meaning of it. Okay, And we have that meaning in C++ to remember in C++. If you say a function is a final function, like in your homework, that means you're not going to override it. You can't override it. Okay. So let's see an example of a final instance variable. Here it is. I have a class named increment. It has two fields. Okay. One is an instance variable total. One is a class variable increment. Sorry. Both of them are instance variables. One is a final variable. Okay. The other one is a non-final. So I can change this one as much as I want, but this one is a constant. It's not going to be changed. I will set its value in the constructor. After that, for the whole life duration of the object, I'm not going to change it. So this is the constructor. Constructor just takes a value and sets it to increment. Okay. So the very simple constructor. Two fields. One of them is final, and this increment will not change. If somebody calls this method add increment to total, all it does is it just adds this value to total. Total is at the beginning is 0. It's initialized to 0. Okay? So I know that this add increment to total or toString or any other methods in my class, we cannot change the value of increment. That's why increment is capitalized. It is written in capital letters. That's the custom in Java or in C++. Okay, always use capital letters for your constant variables. I mean, the term constant variable is kind of funny, right? You say it is variable, it varies, but that's saying you say constant. What kind of a variable is a constant? I mean, a variable is a variable, constant is a constant. It's kind of, there is an irony there. That's why in Java they say final variable. Okay? Final variable sounds more logical. Well, they are the same thing, but it's the terminology, right? So they call it final variables. So final variable is increment. You cannot change it. And I have my toString method. ToString method just converts this object to a string. That's what it does. Whenever you call it, okay, it returns a string, and in this case, it returns total and total. Okay, there is a method named format inside the class string. It's a static method format. Okay, all it does, so what does this do? What is the corresponding function that we have in C? In C, what is the corresponding method? This one will print, this will not print, it will return a string that says total is equal to 5, etc. What is the corresponding function in C? fprintf, right? fprintf. Okay, so you set a string with this string and you return that string. Okay, that's what the string format does. Okay, and I return that one. And again, this toString is inherited from the class object. Everybody knows that in Java all the objects should have a toString method. Okay, everybody should have a toString method. If you override it, it behaves the way you like. If you don't override it, I think it prints the type of the object and its memory location inside JVM, something like that. So usually if we are going to use it, we override it. Okay? Usually if we are going to use it, we override it. What happened to my, oh, okay. Let me notepad. This notepad++ can handle Java. Yeah. See? It knows the Java keywords. Remember this simple program? Okay. It just adds two numbers. I am going to do this. Okay. System out print line delete all that stuff. But okay, my object is just this. Okay. So this one says that I am going to print a string, right? Line 41. Line 41. So one says that I am going to print a string. So what is your string object? Well, object is not a string, but Java says that I know how to convert an object to a string. So I am going to call it toString method, and this will compile and run. Let's compile this, add num. I don't know where that was, but okay, here it is, okay. Java compiler add num. Okay, I compiled it, and let's run this. Add num, it says, did I save it? I think I didn't save it. I saved it, compile it, and run it. See, this is what I get. This is the first print line. This is the second print line. It says that the toString method just returns this. It's the addNum is the name of the class. So each object knows its class name, and this is the address of that object in Java virtual machine, virtual memory. Okay? So that's what it does if you don't override. If you override it, you can do whatever you want, but the nice thing is, this one will work. So by default, remember the stream insertion operator that we have to overload in C++ for the objects. In Java, you don't have to overload anything. You don't have to override anything. All the objects are by default printable because they can be converted to strings automatically using toString method. But it doesn't behave the way we want. It doesn't make much sense whatever it is doing. But if you don't like it, you just override the toString method, and it's going to. Okay. So good. So let's go back to our slides. We talked about this, and let's talk about those. Remember those import statements? Those are called packages. Packages are kind of libraries. In Java, we like to put our stuff inside libraries. Okay. Libraries are maybe, you can think them like as namespaces. Okay. These packages, I don't want to say exactly the namespace, but they look like namespaces, and they are between namespaces and libraries. That's why, I mean, this table at the beginning I kind of like this, but I'm not liking this much because I am not saying not that correct things, but I'm going to do it anyway. Sorry. So in Java we have packages. Packages are like namespaces and maybe some libraries. Okay. But I mean, this is not getting very precise, but I mean, these are just a way of discussing this kind of stuff, making this kind of comparisons. Sometimes the comparison doesn't make sense, but well, it's a starting point. So you need to let's talk about namespaces. We like to put our related class inside the same namespace. Whenever you use them, we use the namespace, right? Using space statements. The packages are kind of the same. So each package is given a unique name, and usually we use this kind of a notation. So if I am working for this company under this project and under this sub-project, and that would be my package name. So if I am developing a package at this university, that would be my package name, tr.edu.gtu.computer science and engineering, okay, CSE 241 dot, okay, project 1. Okay, so this project 1 of this class, I am developing this package. So nobody on this earth other than members of this project can have the same name, right? Because I mean it starts with my internet website name, my email address. Nobody has the same email address as I am in this world. So that way, in the Java world, if you follow the rules, it is very difficult to get two package names being the same or two namespaces being the same, because that was a problem with the, remember, that was a problem with the C++ namespaces. We said that use names, unique namespaces, and everybody was using their last names. Okay, so this is how you do package creating thing, and creating packages is as easy as creating namespaces. And let's look at this one. That's what you say. Okay, at the beginning of your file, you say, I have a new package, or I have a package, I am contributing this package. This is my package name, and this is my class name inside this file. You may add more classes to this package as long as you put this line at the beginning of it. So there are several files, 10 files, 20 files, 30 files in the same directory, and each one is including this line at the beginning of the file. Okay, at the beginning of the file. And these classes, they all go into this package of com detail Java how to program P6 chapter 8. Okay, whenever you are going to use this time one class, you have to import it now. Okay, so the question for you, if I don't include this line number 3, for example, this program, I did not include anything in there, so this one is not going to any specific package. Where does it go? Unnamed package, exactly. So the logic is same with the C++. And remember, in C++, if you don't define a namespace, it goes to unnamed namespace, okay, or unnamed namespace of that compilation. Well, now, not exactly the same. In C++, it goes to the global namespace without giving a name, or if not mentioning any stuff. In Java, you don't have the global package, you have the unnamed package. So this one goes to the unnamed package. Okay, so that's a little bit different. So on the way you use the unnamed namespaces and the way you use unnamed packages are a little bit different in Java. Okay, there are no global packages in Java. There are unnamed packages. Whatever you do without giving a package name, it goes to the unnamed package. Okay. In C++, you have to say, I am writing a namespace, and you don't give any name, so it becomes an unnamed namespace. Okay, so this is how you write your packages. And to be able to use these packages, okay, again, you need to import them using the import statement. And import is similar to using statement. Okay, why did I say, okay, packages are like both namespace and libraries? Because in C++ we make libraries and we put them together into DLLs or .lib libraries. In Java they do the same thing with the packages. Okay, they put the packages together and they can be imported very easily whenever we need them. Okay, so there is no linking in Java, as you have seen. We didn't link any programs with any libraries. That's one thing. Also, you don't see any include statements in Java. Those mechanisms are different. Okay, good. Let's look at the inheritance. The idea of inheritance is there and it's the same. Reusable code, write reusable code. Okay. you have a class that has the basic functionality, that has the common code, common data in it. Later, you extend new classes from it. So the terminology is a little bit different, but the ideas are exactly the same. In Java, this is what we do. If I have a class named A, and through inheritance I made another class B, this process called as extension. I extended class B from A. It is not derived, okay? It's not derivation, it is extension, we extended. Okay? This one is a superclass. Superclass. It is not base class, it's a superclass. This one is a subclass. Okay? It's not derived class, subclass, and superclass, and this process is B extends A. So B adds more capabilities to the superclass A, and this procedure is called extension. Okay, so that's some terminology. Let's write the terms there. Add more lines. Okay, inheritance is inheritance. In Java, instead of saying derive, okay, we said extend. Base class is superclass, and derived class is subclass. Okay, remember our example of, for example, what? I have a motor vehicle, and I have automobile, superclass and subclass. The set of automobiles are a subset of motor vehicles, right? So sets, superset, and subset. Küme alt küme. It's like that, okay? Superclass and subclass. B is a subclass of A. Okay, because there might be more classes like this. Okay, B and C are subclasses of superclass A. It's like set, subset, and superset relationship. Alt küme, üst küme kind of thing. Okay, so that's the terminology. So we know what the inheritance is, why we are using it. Let's see an example. Okay, and it's a familiar example. Commission employee, it's going to be our superclass, base class. Commission employee has this first name, last name, social security number, gross sales, and commission rate. Remember how the commission employee makes his or her money? He says that I sold this much worth of goods and my commission rate is 5%, so I am going to get $1,000 times 0.05. I am going to get $50 out of this. Okay, that's called the commission employee. And here's our constructor. It takes the first name, last name, social security number, sales, and rate. Set, assignment, and I am calling what? I am calling the set gross sales and set commission rate, right? And that will be it for the constructor, no problem. So I am not going to tell you many neat things in this slide, okay? This is just a regular class, commission employee class that we have written for C++ before. And setters are there, setter, getter, set last name, get last name, set social security, get social security, gross sales, commission rate, lots of stuff, earnings, okay? This is my earning, this is how much money I make. commission rate times gross sales. Okay, and my toString method, it just uses the same string format method. I print all of this stuff to this string, I return it. And that's the whole class commission employee. Now I am going to extend a new class out of this commission employee. It's going to be base class commission employee. So my hierarchy will be, this is my commission employee. I am going to derive a new class, base plus commission employee, base plus commission. That means what? This guy makes his money by selling goods. Also, I have to pay him some constant base salary every week. Okay? So some money every week plus the commissions of it. So it is very similar to commission employee. It makes sense to extend this class out of this superclass. So that's what I do. Public class base plus commission employee extends commission employee. Okay, so on top of the private, were those private or protected? Did we make them private? No, they are all protected. So the name of the meaning of the protected is the same. So I make a new field, okay, instance field, instance data member, okay, instance variable base salary. It is private, and this is my constructor. These are for first name, last name, social security, sales and rate are for the superclass. This is for me. So I send all these 5 things to my superclass. This is how you call the constructor of your base class or superclass. There is a keyword named super. In C++, we don't have such a keyword. In Java, it is there. So super constructor gets this. Remember this keyword, how we delegated our constructors before with this keyword? This is something like that. Instead of calling my constructor, I am calling the superclasses constructor. I call the superclasses constructor, then after that, it is a set base salary. This super, like this constructor delegation, has to be the first executable statement in my constructor. Before that, I should not have any executable statements. Remember how we solved this problem, the first executable statement? We used to put a column there and we used to call our base classes constructor in C++, right? So that way, before our functions can begin execution, it calls the base classes constructor. It is the same thing here. Good. Any questions so far? So I am going to what? I am going to write 2 methods for set base salary, get base salary. That's it. Oh, I need to override this earnings method. Earnings is like base salary plus. Well, instead of saying this, I think I should have done this. This would be better. I should have said super dot earnings. Okay. So I am calling the base superclasses earnings method. Whatever it returns, I add the base salary and I am done. And for this one, maybe I should have said get base salary. Get base salary plus super dot earnings. Okay? Good, good. So toString, of course, I am going to override it. This one again is doing something that's not good because I have already implemented this printing this first name, last name, social security number, gross sales, and commission say, okay? So this was already done. Why am I repeating it? So I am going to do this instead of that, okay? Return string dot format, okay? %s okay, and then another percent s, and dot to f. So I am going to do this. I am going to call super, okay, and comma base salary, comma base salary. That's it, okay? Let it go. Oh, come on. Okay, yeah, okay. So this is what I would have done. So super is not a string, but super has a toString method, right? So the compiler knows how to convert the super, my super class, to a string. I convert it to a string, then I have my base salary here, and I have my base salary as a float, and that would be it. Okay, any questions? And of course, I am going to write my test class, commission employee test class. My main, I have a commission employee, I have a base plus commission employee. 1, 2, 3, 4, 5, 6 things. This one is my base salary. And even though I did not write get first name, get last name, get social security number for this class, this extended class, this subclass, they all work fine, okay? And at the end, I use this toString. Well, in that case, you didn't have to call this toString because the compiler can automatically call it. Compiler knows how to convert an employee to a string by calling the toString method of it. Okay? Question for you. If I said, instead of this one, if I said commission employee, would this compile and run? Would I get any error messages for line 9, 10, and 11? Would I get any error messages for line 17, 19, 21, etc.? Think about this. I am going to take a break. Let's be here around 9:35. When we come back, okay, we are going to talk about this question. Okay? 15 minutes. Camları açalım arkadaşlar ya, içerisi havalansın. Efendim? Onun için geldim değil mi sabah sabah ya? Uyuyacaksan arkaya geçip uyusana.